The Brandenburg summer pressed down like a leaden shroud, the horizon shimmering with heat haze as Major Vera Tierfelder approached the American fighter dominating Rechlin Air Base's tarmac. July 20th, 1944. The machine shouldn't exist. Its drab olive paint was flaking, clumsy daubs of iron crosses slapped over the ghostly stars of the U.S. Army Air Forces. But paint couldn't mask the Mustang's true form. Slowly, deliberately, she circled the P-51D, like a hawk sizing up strange prey, or perhaps like prey trying to decipher the hunter's secrets. The fuselage was surprisingly lean, almost delicate compared to the robust Focke-Wulfs she usually flew. Her fingers traced the wing's leading edge, feeling the smooth curve of the laminar flow airfoil, a whispered secret among German engineers, never quite replicated in their factories. The aluminum skin was thin, almost fragile. Light, fast, and build 10,000 . That, she guessed, was the American mantra. Vera Tierfelder had 4 years in the Luftwaffe, intercepting RAF bombers over England, then as a test pilot at this clandestine facility north of Berlin. She'd flown captured Soviet Yaks, crude, reliable machines she likened to winged tractors. She'd tested British Spitfires, deadly in a dogfight, but with a fuel capacity that was almost comical. There was the American P-47 Thunderbolt, the Jug, a massive radial-engined fighter the German pilots mocked for resembling a milk bottle, devastating in a dive, but too unwieldy for a sustained aerial ballet. This aircraft was different. The reports from the Western Front were becoming frantic, desperate. Luftwaffe pilots spoke of a fighter that defied the laws of physics. A long-range escort fighter times should not times exist. German aerodynamic theory stated that the fuel needed for extended range would make an aircraft too sluggish for combat. Yet somehow the Americans were escorting their bomber formations to Berlin and back, and the escort was outfighting Germany's best. This Mustang had gone down near Arkham 2 weeks before. Its Packard-built Merlin engine had coughed and died after the pilot radioed about contaminated fuel. He'd crash-landed in a field, the aircraft largely intact. Wehrmacht troops had secured it before he could torch it. Within hours it was being rushed east, away from the Allied advance, toward Rechlin. Tierfelder's mission: evaluate the aircraft, determine its strengths, its weaknesses, confirm or deny the combat reports, find something, anything, German pilots could exploit. She climbed onto the wing, slid into the cockpit. The seating position was immediately striking, higher than in German fighters, granting phenomenal visibility. The cockpit was a bubble, a single curved sheet of plexiglass, unbroken by framing. She could see in every direction. The Messerschmitt Bf 109's heavy canopy framing created massive blind spots. Here, there was nothing. The instrument panel, stretched before her, labeled in English. Someone had pasted small paper slips with German translations. Ladedruck, Kraftstoffgemisch, Kühlwassertemperatur, boost pressure, fuel mixture, coolant temperature. The layout was logical, everything within easy reach. Classic American ergonomics. They designed for the pilot, rather than forcing the pilot to adapt to the machine. She examined the throttle quadrant. The throttle was on the left, which would take getting used to. German fighters placed it on the right. Below it, the mixture control and propeller pitch levers. The Americans used constant speed propellers, automatically adjusting the blade angle to maintain optimal RPM. Another example of their thinking: automate what could be automated, so the pilot could concentrate on the fight. The Rechlin engineers had meticulously recorded the technical specifications over the past week. The Packard V16507 engine, essentially a license-built Rolls-Royce Merlin 61, produced 1,490 horsepower in wartime emergency power with water methanol injection. The two-stage, two-speed supercharger maintained power at altitudes where German engines gasped for air. The propeller was a four-bladed Hamilton Standard, 11 feet in diameter, empty weight, 7,040 pounds. Maximum takeoff weight, 12,100 pounds. That was with full internal fuel and ammunition. Add 2 external drop tanks and the weight soared to over 14,000 pounds. Yet, combat reports indicated the aircraft remained agile. Armament was all guns. 6. 50 caliber Browning M, 2 machine guns, 3 in each wing. No cannon, unlike German practice. The Americans had gone for volume of fire over raw power, gambling that a high volume of 50 caliber rounds would compensate for the absence of cannon shells. Luftwaffe pilots claimed the Mustang's guns were brutally effective, especially in deflection shots, where the high rate of fire created a cone of projectiles. Tierfelder signaled the ground crew. They moved around the aircraft, wheel chocks ready, fire extinguishers in hand. No one was sure if this American engine would start reliably on German fuel. Merlins were notoriously picky about fuel quality. They needed high-octane gasoline, which Germany couldn't produce enough of. They were using captured American fuel, recovered from overrun depots in France for this test. She followed the translated startup procedure taped to the instrument panel. Fuel mixture rich, throttle cracked slightly open, magneto switches on both. Her thumb found the starter button. The engine turned over. Once, twice, then caught. The four-bladed propeller began to rotate slowly, then blurred into an invisible disc. The distinctive sound of the Merlin filled the air, a deep, throaty rumble, completely different from the harsh mechanical snarl of the Daimler-Benz DB605. There was a refinement to it, an impression of precision manufacturing and tight tolerances. The British had designed this engine in the 1,930 seconds as a racing engine, then adapted it for the Spitfire. The Americans had taken that design, streamlined the manufacturing process, and produced it in numbers that the German industry could not match. Tens of thousands of Merlins had been built. They powered the Mustang, the Spitfire, and the Lancaster heavy bomber. It was arguably the most successful aircraft engine of the war, and it wasn't German. This troubled Tierfelder more than she cared to admit. She'd grown up on the myth of German engineering superiority. The Reich's propaganda machine had cultivated the image of German technology as the best in the world. The early victories of 1940 and 1941 had seemed to confirm this narrative. German tanks had swept through Poland and France. The Luftwaffe had annihilated the Polish Air Force and inflicted crippling losses on the French. Even the RAF had been held at bay over Britain, or at least that was the official story. But 1944 told a different story. The Luftwaffe was losing pilots faster than they could be trained. Aircraft production was increasing. The factories churned out Messerschmitts and Focke-Wulfs in record numbers. Yet, German fighters were being destroyed faster than they could be replaced. Not because of production capacity, but because of a widening gap in quality, both in machines and in pilots. American pilots arrived in Germany with 200 to 300 hours of flight training. German pilots now received 30 to 50 before being thrown into combat. The Americans flew aircraft that defied the supposed laws of aeronautical engineering. The Germans flew refined versions of designs from 1939, incremental improvements to obsolete concepts. Tierfelder began to taxi, guiding the Mustang towards Recklin's main runway. The steerable tailwheel, linked to the rudder pedals, provided precise ground control. Visibility over the nose was adequate, better than in the Bf 109 with its narrow undercarriage and nose-high stance, though not as good as the Focke-Wulf 190's broad-shouldered configuration. She ran through the pre-flight checks, flight controls free and correct, trim tabs set for takeoff, fuel selector on main tank, fuel mixture rich, propeller pitch fully forward, flaps set to the takeoff position. The Americans didn't use flaps for routine takeoffs, relying instead on the wing's inherent lift characteristics. Air traffic control cleared her for takeoff. She turned onto the runway, aligned the nose with the centerline, and slowly advanced the throttle. The acceleration was immediate and forceful. The Merlin's power slammed her back into the seat as the Mustang surged forward on the concrete. The tail lifted quickly, dramatically improving visibility. The airspeed indicator climbed. 100 kilometers per hour, 150, 200. At 220 kilometers per hour, Tierfelder gently pulled back on the stick, and the Mustang lifted effortlessly into the air. The runway fell away behind. 400 meters of ground roll. Her Focke-Wulf 190 usually required 600, another advantage. Gear up. The landing gear retracted into the wings with a solid times, thunk times, and the characteristic rumble of operating mechanical systems. And then almost instantly, instinctively, Tierfelder felt something unexpected. The Mustang accelerated as if it had been unleashed. There was no struggling against drag, no sense of the aircraft straining to convert power into speed. It simply times went asterisk. The airspeed needle climbed steadily, 250, 300, 350 kilometers per hour. She was only at 1,500 meters, and the Mustang was already moving faster than many German fighters at their maximum velocity. The aircraft climbed over the Brandenburg countryside, passing 2,000 meters, 2,500. Tierfelder made small adjustments to the controls, feeling the Mustang's response. The ailerons were light but effective. She could bank the aircraft with minimal effort. Elevator was smooth, progressive, with no tendency to be twitchy or over-controlling. Rudder input was minimal even in the climb. Engine torque was well balanced. This was an aircraft designed for long missions. Everything about the handling suggested an emphasis on pilot comfort and fatigue reduction. A German fighter demanded constant attention, ceaseless micro-adjustments. The Mustang seemed content to fly itself while the pilot navigated, maintained formation, or searched for the enemy. At 3,000 meters, she leveled off and began a systematic evaluation. Gentle turns to the left, to the right, steeper banks. The Mustang responded predictably, progressively. No bad habits, no tendency to snap, roll, or spin. Asterisk, stable to the point of being almost boring. Asterisk, she thought, which was precisely what you wanted for a fighter that had to escort bombers for hours over enemy territory. Then she opened the throttle fully in maximum continuous power and pushed forward gently on the stick, transitioning to level acceleration. The response was extraordinary. The airspeed needle climbed at an alarming rate. 350 kilometers per hour, 400, 450, 500. The Mustang was still accelerating. 550, 600, 650. At 4,500 meters, the aircraft reached 715 kilometers per hour, approximately 444 miles per hour in American terms. Tierfelder had flown the Focke-Wulf Fu-190A, one of Germany's premier fighters. Widely regarded as one of the best interceptors the Luftwaffe possessed, that aircraft achieved a maximum speed of approximately 653 kilometers per hour at its optimal altitude. The Messerschmitt Bf 109G, the backbone of the German fighter squadrons, rarely exceeded 621 kilometers per hour under ideal conditions. This American fighter wasn't just marginally faster, it was faster in a way that fundamentally altered the tactical equation of aerial combat. A 60 kilometers per hour speed advantage meant a German pilot couldn't catch a Mustang that was running away, couldn't escape a Mustang that was pursuing, couldn't dictate the terms of engagement. The American pilot chose when to fight and when to disengage. The German pilot had no choice but to accept whatever the Mustang pilot decided. 4 years of war had taught Tierfelder that speed in aerial combat wasn't just about going fast, it was about controlling the engagement. The faster aircraft decided whether a fight happened at all. In fighter versus fighter combat, this was decisive. She nosed down and began an altitude test, pushing the throttle to wartime emergency power. The water methanol injection system activated, injecting the mixture into the supercharger to suppress detonation and allow the engine to generate maximum power. The Merlin's roar deepened as it produced its full 1,490 horsepower. The Mustang climbed aggressively through 5,000 meters, 6,000. German fighters began to lose performance at this altitude as their single-stage supercharger struggled to compress the thinning air. The Mustang's two-stage supercharger, a British engineering masterpiece refined by American manufacturing, maintained its output, 7,000 meters, 8,000. At altitudes where the Messerschmitt became sluggish and unresponsive, where the Focke-Wulf strained to maintain its speed, the Mustang felt perfectly at home. The controls remained effective. The engine produced smooth, reliable power. This was the aircraft's element. 9,000 meters, 10,000. At 10,000 meters, 32,800 feet, the Mustang was still climbing at over 4 meters per second. The official service ceiling was listed as 12,070 meters, but Tierfelder suspected the aircraft could go higher if she asked it to. This explained everything. The combat reports were not exaggerated. If anything, they were understated. American heavy bombers operated at altitudes of 7,000 to 8,000 meters, where German flak was less effective and where hypoxia affected German fighter pilots, who often had inadequate equipment. The Mustang escorts operated above the bombers, between 9,000 and 11,000 meters, where they could dive down on any Luftwaffe interceptors climbing to attack. German pilots had to climb through the bomber formations, through the concentrated defensive fire of hundreds of 50 caliber machine guns, then engaged the fighters at an altitude where their own aircraft were struggling to perform, while the Mustangs were operating within their optimal range. It wasn't a fair fight. It wasn't designed to be a fair fight. Tierfelder leveled off at 8,000 meters and began a series of maneuverability tests. She rolled the Mustang to the left, then to the right, assessing the aileron response at altitude. The controls remained crisp, responsive. She pulled into a climbing turn, feeling the G-force pressing her into her seat. The aircraft held the turn without wallowing or slipping. She reversed, rolling right and pulling hard. The Mustang responded instantly, transitioning smoothly from one high-G turn to another. This was where she expected to find a weakness. Long-range fighters traditionally sacrifice maneuverability for endurance. The added weight of fuel, the aerodynamic compromises necessary for extended range, these would make the aircraft less competitive in a turning fight. Spitfires turned beautifully, but carried fuel for barely 2 hours of combat. The American P-47 Thunderbolt had excellent range, but handled like a lumbering beast, relying on speed and diving attacks rather than sustained turning engagements. The Mustang seemed to defy this supposed dichotomy. It turned aggressively, not quite as tightly as a Bf-109 at low altitude. The German fighter's light wing loading gave it an advantage in pure turning radius, but far better than any long-range fighter had a right to turn. And at altitude, where the thin air reduced the effectiveness of the 109's small wings, the Mustang's larger wing area provided superior lift. Up here, above 7,000 meters, the Mustang could actually outturn a Messerschmitt. She continued her evaluation, systematically recording the aircraft's handling characteristics at various speeds and altitudes. Slow flight, stable, with ample stall warning through buffeting. The stall itself was benign, with no tendency for a wing to drop or to enter a spin. Recovery was straightforward. Release back pressure, add power, regain airspeed. High-speed handling. The aircraft remained stable and controllable. No flutter, no excessive vibration. The controls became heavier at high speed, requiring more force, but remained progressive and predictable. This was a well-designed machine. The heavy controls helped prevent the pilot from overstressing the airframe with abrupt maneuvers at velocities where structural limits became critical. Now came the test that would reveal the most: high-speed dive characteristics. German fighters had a troubled relationship with diving attacks. The Bf, 109 inches particular, suffered from compressibility issues at high speeds. The crux of the problem lay in compressibility issues at high speeds. As an aircraft neared the sound barrier, a speed lower at altitude due to the frigid temperatures, airflow over the wings and control surfaces began flirting with supersonic velocities. Shockwaves materialized, rippling across the airframe. Control surfaces became sluggish, unresponsive, or seized up entirely. The aircraft entered a state from which the pilot was powerless to recover, tumbling towards the earth until either the dive flattened out at lower altitudes, where the speed of sound was higher, or the airframe disintegrated under the immense aerodynamic loads. Many Luftwaffe pilots had met their end in precisely this manner. Training emphasized extreme caution during high-speed dives: engage, attack, but never pursue a diving enemy beyond specified velocity limits. Survival depended on it. Tierfelder nosed the Mustang downward, 15 degrees below the horizon, 20, then 30 degrees. He pushed the throttle forward, injecting extra power into the dive. The airspeed indicator began to climb with increasing urgency. 500 kilometers per hour, 550, 600. The aircraft remained stable, tracking straight and true. 650, 700. He steepened the dive to 45 degrees. The ground rushed up to meet them. The verdant patchwork quilt of Brandenburg farmland, crisscrossed by roads and dotted with villages, expanding rapidly across the windscreen. 750 kilometers per hour, 800. The controls remained responsive. He could feel the increasing pressure on the stick, a tangible resistance. Aerodynamic forces pushed back against his inputs, but the ailerons and elevators continued to bite into the air, answering his commands. There was no buffeting, no ominous vibration, no hint of impending structural failure. The Mustang was now plunging earthward at over 800 kph, close to 500 miles per hour, and it felt controlled, almost disconcertingly normal. At 805 kph, Tierfelder hauled back sharply on the control stick. The aircraft responded instantly. The nose lifted. G-forces built rapidly, 3-4 Gs, pinning him back against the seat, blurring his vision at the periphery. The dive flattened out, transitioning into level flight, then into a climb. The Mustang bled off speed rapidly, trading velocity for altitude, stabilizing at 4,000 meters. No structural issues, no control problems, no nasty surprises. This was the final piece of the tactical puzzle. A Luftwaffe pilot attempting to escape a Mustang by diving would not escape. The Mustang could follow him down, remaining controllable at speeds that rendered German fighters unresponsive and still possess ample energy to climb back afterwards. There was no safe escape vector, save perhaps a desperate low-altitude dash, where the proximity to the ground might deter pursuit, but even that was now highly questionable, given the Mustang's superior visibility and handling characteristics. Every tactical advantage that German pilots had relied upon for 4 years of aerial combat, speed, altitude, diving attacks, had been comprehensively neutralized by this single aircraft design. Thierfelder began his descent back towards Rechlin, throttling back to conserve fuel. The Mustang still held close to 70% of its fuel after 40 minutes of intensive flight testing, including multiple climbs to altitude and high-speed runs. The fuel management was exceptional. The internal fuel tanks held 1,100 pounds of fuel, approximately 170 gallons. Add 2 external drop tanks, 110 gallons apiece, and the total fuel capacity reached a staggering 390 gallons. These figures translated into a combat radius of approximately 750 miles with drop tanks. The Mustang could fly from England to Berlin, a distance of nearly 600 miles, escort bombers over the target, engage in combat, and return to England. No German fighter could claim anything remotely similar. The Bf-109G had a combat radius of approximately 200 miles. The W-190A managed perhaps 320 miles with a drop tank. German fighters were tethered to their bases. They scrambled, climbed to intercept, engaged the bombers, landed to refuel and rearm. If drawn away from their bases by American escort fighters, they had to break off combat to reach an airfield before their fuel ran dry. The Americans faced no such constraints. They could remain over German territory for hours, an ever-present, looming threat. The strategic implications were devastating. He entered the landing circuit at Rechlin, reducing power and extending the landing gear. The Mustang slowed smoothly to its approach speed. Flaps down, the nose dipped slightly, requiring a touch of back pressure on the stick to maintain the glide slope. Over the runway threshold, throttle to idle, gently ease back on the stick, main wheels kissed the concrete. Tail settled, and the Mustang rolled straight and true. 47 minutes in the air. 47 minutes that had fundamentally altered Thierfelder's understanding of aerial warfare. He taxied back to the dispersal area, where the ground crew and his assigned engineer were waiting as he cut the engine. The Merlin idled down with a diminishing whine, then fell silent. He marshaled his thoughts. The report he would file had to be accurate, technical, and above all, honest. The Luftwaffe High Command needed accurate information, not comforting falsehoods. But there was another dimension to what he had just experienced, something that transcended technical specifications and performance data. He had just flown an aircraft that represented a comprehensive repudiation of everything that German aeronautical doctrine had assumed about long-range fighter design. The Rechlin base had been testing captured Allied aircraft since the beginning of the war. Early Soviet fighters were crude but effective. The British Spitfire impressed but was limited by its short range. The American P-47 Thunderbolt was powerful but ponderous. Each aircraft had clear strengths and identifiable weaknesses that German fighters could exploit. The P-51 Mustang possessed strengths in every category and no exploitable weaknesses. It was faster than German fighters at all altitudes. It climbed higher above 6,000 meters. It dived better at all speeds. It turned well enough to dogfight. It had a range that made German fighters look like trainers. It possessed better visibility than any Luftwaffe fighter. It had reliable systems and an engine that produced smooth, predictable power. And here, perhaps, was the most psychologically challenging aspect of all. It was not produced in small numbers by master craftsmen in specialized workshops. It was mass-produced in American factories by semi-skilled workers. Thousands rolling off the production lines at a rate that German industry could not begin to match. Over the next 3 days, Thierfelder and his team compiled their official evaluation report. The document was methodical, meticulously organized and damning in its conclusions. Performance summary. Maximum speed at 4,500 meters, 715 kilometers per hour. Service ceiling, 12,770 meters. Rate of climb at sea level, 16.3 meters per second. Combat radius with drop tanks, 1,210 kilometers. Endurance at cruising power, 4 hours, 15 minutes. Comparative analysis with the Focke-Wulf Fall W190A8. The Mustang was faster at all altitudes, climbed higher above 6,000 meters, dived better, and possessed 3 times the combat radius. The Ford W190 retained an advantage in roll rate at low altitudes and possessed heavier firepower with its cannons. Overall assessment. The Mustang was superior in most combat situations. Comparison with the Messerschmitt Bf 109 G6. The Mustang was faster at all altitudes, climbed higher above 5,000 meters, dived significantly better, and possessed 3 times the combat radius. The Bf 109 retained an advantage in sustained turn rate at low altitudes and possessed equivalent firepower. Overall assessment. The Mustang was superior in most combat situations. Tactical implications. The P-51D represented a fundamental shift in fighter design philosophy. German fighters prioritized heavy firepower, rugged construction, and competitive performance within the typical European combat environment at altitudes between 3,000 and 6,000 meters. The Mustang achieved its performance through aerodynamic efficiency, an exceptional engine mated to an optimized airframe, and a revolutionary laminar flow wing design that reduced drag. Most importantly, the aircraft's range allowed. It fell to the captured Mustang to deliver a stark truth. Even if German engineers could magically duplicate every inch of its design overnight, Germany simply lacked the industrial might, the raw materials, and crucially, the time to mass-produce such an aircraft. The Mustang's Packard Merlin engine, a masterpiece of engineering, guzzled high-octane fuel, a commodity Germany could scarcely afford. To create enough, they were forced into expensive and complex synthetic production, all while Allied bombing raids increasingly targeted those very synthetic fuel plants. By the autumn of 1944, Luftwaffe fighters were becoming glorified lawn ornaments, grounded not by mechanical failure, but by the crushing reality of empty fuel tanks. The Mustang's very skeleton, its airframe, was crafted from aluminum alloy, another resource that Germany had to either import at exorbitant prices or synthesize through equally costly processes. Meanwhile, American industry was churning out aluminum in volumes that dwarfed German production. Each individual Mustang required roughly 1,000 man-hours to assemble, a substantial investment, yet American factories were spitting them out at a mind-boggling rate of over 400 per month. German fighter production, despite Herculean efforts, was struggling just to keep pace with the relentless toll of combat losses. And even if Germany could somehow conjure up a Mustang equivalent, they faced another crippling shortage: pilots. Luftwaffe pilot training programs were crumbling under the combined weight of fuel scarcity and the desperate need to funnel replacement pilots to the front lines. Newly minted German fighter pilots were receiving a mere 30 to 50 hours of flight training before being thrust into the brutal chaos of combat. Their American counterparts, in contrast, enjoyed a far more robust 200 to 300 hours of training, much of it conducted on aircraft remarkably similar to those they would be flying in actual combat. The Americans weren't just winning a technological skirmish. They were utterly dominating the industrial war, the resource war, and the training war. They were, in essence, winning on every conceivable front simultaneously. Tierfelder's damning report, stamped with grim authority, ascended the chain of command within the labyrinthine Luftwaffe bureaucracy. It eventually landed at the headquarters of Jagd-Korps, the very nerve center of the fighter forces command. Staff officers, those responsible for formulating tactics and defining operational doctrine, read it, absorbed its implications, then dutifully filed it away, consigning it to the dusty obscurity of the archives. What the report couldn't alter was the inexorable tide of the strategic situation. By July of 1944, the Luftwaffe was locked in a defensive war it simply couldn't win. The Normandy landings had succeeded against all odds, despite the vaunted German air resistance. Allied fighters and bombers were operating over German territory with ever-increasing impunity, casting a long shadow over the Reich. The Luftwaffe's meticulously constructed fighter defense system, A complex web of radar stations, ground controllers, and regional fighter squadrons was being systematically overwhelmed and dismantled. If you are finding this story compelling, please take a moment to subscribe and turn on notifications. It helps us continue to produce in-depth content like this. The test flight at Rechlin wasn't some earth-shattering revelation. It merely validated what hard-won combat statistics had already screamed from the rooftops. In July 1944 times alone asterisk, the Luftwaffe hemorrhaged approximately 450 fighter pilots, lost to the gaping maw of combat, killed, missing, or captured. This catastrophic attrition rate was a wound that pilot training programs could not even begin to heal. American losses were substantial, yes, but American training schools were pumping out pilots faster than they were being lost. The German program, in stark contrast, was producing pilots at a rate slower than they were dying. The Mustang was more than just a superior fighter. It was the tangible, steel and aluminum manifestation of American industrial, technological, and organizational supremacy. It was irrefutable proof that the United States could conceive, design, manufacture, and deploy a weapon system that was demonstrably superior to German equipment, and then produce that system in quantities that utterly dwarfed German output. On the 25th of July, 1944, a mere 5 days after Tierfelder's groundbreaking test flight, the captured Mustang was sent aloft once more, this time with a different pilot at the controls, eager to independently verify the findings. The results were chillingly identical. The aircraft performed precisely as documented. There were no hidden flaws waiting to be exploited, no unexpected weaknesses lurking beneath its sleek skin. The Mustang remained at Rechlin throughout August and September, a subject of constant scrutiny. German engineers photographed every minute detail, measured every crucial dimension, and meticulously analyzed every aspect of its construction. They learned a great deal about American design philosophy and manufacturing techniques, but the harsh reality remained: they simply could not replicate it. Not with the resources they had available, and certainly not with the rapidly dwindling time left on the clock. By October 1944, Allied forces had liberated France and were relentlessly advancing towards Germany's western border. The Rechlin base, once nestled deep within the heart of German territory, was now within easy reach of Allied fighters conducting armed reconnaissance missions. The entire collection of captured aircraft, including the prized Mustang, had to be either evacuated eastward or destroyed outright to prevent their recapture. The precise fate of the P-51D that Tierfelder so expertly evaluated remains shrouded in the fog of war. The most likely scenario is that it was destroyed in place as Soviet forces surged into Brandenburg in the spring of 1945. Alternatively, it might have been abandoned during the chaotic Rechlin evacuation, left stranded on some forgotten airfield as German personnel desperately fled westward. Or perhaps it succumbed to the ravages of an Allied air raid, damaged beyond repair, and ultimately scrapped for its precious metal. Whatever its end, the aircraft vanished from the historical record amidst the utter chaos of Germany's collapse. Tierfelder himself survived the war. He was captured by American forces in May 1945 and spent several months in a prisoner of war camp before finally being released. During the post-war interviews conducted by Allied intelligence officers, who were systematically debriefing Luftwaffe test pilots, he spoke with remarkable candor about his experiences at Rechlin and his brutally honest assessment of Allied aircraft. When specifically asked about the P-51D Mustang, his answer was unequivocal, devoid of any nationalistic sentiment. It was the best all-around fighter of the war, superior to the Focke-Wulf 190, superior to the Messerschmitt 109, even superior to the German jet-powered Messerschmitt Me 262 inches, most practical combat situations, because the Mustang was reliable, available in large numbers, and could be flown confidently by moderately trained pilots. This admission must have been a bitter pill to swallow, a psychologically jarring experience for someone so deeply immersed in the mythology of German technical superiority. But Tierfelder was, first and foremost, a test pilot, a profession that demanded intellectual honesty and the ability to report uncomfortable truths, regardless of the consequences. His assessment of the Mustang was untainted by national pride or ideological allegiance. It was simply the unvarnished product of 47 minutes spent in the cockpit of an aircraft that had irrevocably redefined what a fighter could be. The story of German test pilots flying a captured Mustang and acknowledging its inherent superiority is far more than a mere anecdote about aircraft performance specifications. It represents a profound clash between deeply entrenched ideology and cold, hard technical reality, a stark collision between carefully crafted propaganda and measurable, undeniable truth. The Third Reich had painstakingly constructed much of its identity around audacious claims of technical and industrial supremacy. German engineering was not merely presented as excellent, it was portrayed as inherently superior, a direct manifestation of racial and cultural traits that supposedly made German technology fundamentally better than anything other nations could produce. This wasn't just empty marketing aimed at swaying foreign audiences. It was deeply ingrained internal propaganda that Germans themselves were taught and often believed to be true. The early successes of the Luftwaffe seemed to validate this carefully constructed narrative. In 1939 and 1940, German fighters decisively dominated opposing forces in Poland and France. The Messerschmitt Bf 109 was, without a doubt, a world-class fighter during this period, faster, better armed, and significantly more advanced than most of its adversaries. Luftwaffe tactical doctrine, emphasizing coordinated attacks and seamless radio communication between aircraft, was innovative and undeniably effective. But the Battle of Britain revealed the first hairline cracks in this seemingly impenetrable mythology. The Supermarine Spitfire proved to be a surprisingly close match for the Bf 109 inches overall performance, and in some aspects of maneuverability, even superior. British pilots, fiercely defending their own territory with the invaluable advantage of early radar warning, inflicted unsustainable losses on the Luftwaffe. The planned invasion of Britain was ultimately postponed indefinitely. Yet, even after this setback, the narrative of German technical superiority could still be tenuously maintained. The Bf 109 was continually upgraded with more powerful engines and improved armament. The Focke-Wulf FUV 190, introduced in 1941, was demonstrably superior to the then-current Spitfire Mark V serving in the Royal Air Force RAF. German industry was consistently producing excellent aircraft in significant numbers. What fundamentally changed between 1941 and 1944 was not a sudden, precipitous decline in German technology. German fighter aircraft continued to improve incrementally. The Bf 109G was faster and better armed than the Bf 109E that had terrorized the skies over England. The Fu 190 was constantly refined with more powerful engines and enhanced systems. The crucial shift was in the nature of the opposition. The Soviets began producing fighter aircraft in enormous quantities, aircraft that were often undeniably crude, yet undeniably effective, and available in numbers that rendered German victory through sheer attrition utterly impossible. The Yakovlev Yak-3, introduced in 1943, was lighter and more maneuverable than German fighters at lower altitudes. The Lavochkin La-5FN offered comparable performance to contemporary German fighters and was produced in truly staggering quantities. Mass production, that was the game changer. The United States had brought to bear an industrial capacity that dwarfed that of Germany. American factories churned out over 96,000 fighter aircraft during the war years. The total German production, in stark contrast, amounted to approximately 55,000 fighters of all types. This disparity would have been significant even if the planes had been of comparable quality. But American aircraft were not merely more numerous. By 1943 and 1944, they were technically superior to German designs in almost every conceivable category. The P-51 Mustang represented the absolute apex of this technological development. It wasn't the first American fighter, nor even the first times good times American fighter. It was a carefully orchestrated synthesis of multiple streams of technology: British aerodynamic research into laminar flow wings, the brilliant British engine design embodied in the Rolls-Royce Merlin, American manufacturing expertise in the mass production of complex systems, and American operational experience precisely defining the requirements for a long-range escort fighter. North American Aviation began designing the Mustang in 1940, initially for use by the British. The first prototype took to the skies that October, a remarkably short development timeline of only 120 days from contract to first flight. This rapid development was made possible because North American capitalized on existing knowledge rather than attempting revolutionary innovation. The laminar flow wing was based on extensive research conducted by NACA, the National Advisory Committee for Aeronautics, the precursor to NASA. The airframe structure utilized conventional aluminum construction techniques. The engine was an existing British design, being manufactured under license by Packard. The initial Mustang, fitted with an Allison engine, was fast at low altitudes but lacked the necessary performance at high altitude. It served effectively in ground attack and reconnaissance roles, but it wasn't a competitive air-to-air superiority fighter. The game-changing breakthrough came when someone accounts differ as to who first suggested it, proposed fitting the magnificent Merlin engine in place of the Allison. This combination was nothing short of transformative. The Merlin's sophisticated two-stage supercharger sustained power at high altitudes where the Allison faltered and wheezed. Suddenly, the Mustang became not just fast, but devastatingly fast at times, all times altitudes. The P-51B, which first flew in December 1942, demonstrated superior performance to all existing fighters. The P-51D, with its distinctive bubble cockpit and increased ammunition capacity, further refined the design. By mid-1944, when Tierfelder flew the captured aircraft at Rechlin, the Mustang was being produced at a staggering rate of over 400 per month. Total P-51 production would eventually exceed 15,000 aircraft, nearly equaling the total production of all Focke-Wulf W-190 variants throughout the entire war. This industrial capacity was, in and of itself, a formidable weapon. Even if German fighters achieved favorable kill ratios in individual engagements, and by late 1944, they often did, the inexorable attrition math overwhelmingly favored the Allies. The Americans could lose aircraft and replace them in a matter of weeks. The Germans simply could not. But the captured Mustang at Rechlin forced the German test pilots to confront something far more psychologically challenging than mere numerical inferiority. They were forced to admit that the American aircraft was not just more numerous, but demonstrably times better asterisk. Better in ways that could be objectively measured and irrefutably proven. Ways that could not be brushed aside with flimsy excuses about pilot training or tactical circumstances. The Mustang was faster. This could be verified with a stopwatch. It climbed better at high altitude. This could be precisely measured with an altimeter and a stopwatch. It had longer range. This could be accurately calculated from fuel consumption rates. Its controls were beautifully harmonized, providing exceptional responsiveness and precision. This could be felt directly through the control stick. Every measurement, every test, every objective evaluation relentlessly pointed to the same damning conclusion. The Americans had definitively surpassed Germany in aircraft design. This wasn't supposed to be possible. According to the tenets of Nazi racial ideology, Americans were portrayed in German propaganda as culturally inferior, their society hopelessly weakened by democracy and racial diversity. How could such a fundamentally flawed nation possibly produce technology demonstrably superior to that of the pure, disciplined, and organized German Reich? The cognitive dissonance must have been profound for those who genuinely believed the propaganda. For pragmatists like Theopelder, however, the evidence was simply the evidence, perhaps unpleasant, but utterly undeniable. The test flights at Rechlin were not isolated incidents. Several P-51 seconds had been shot down or captured relatively intact during the war. Each one was meticulously studied and exhaustively analyzed. The conclusions were invariably the same. In one recorded instance, a Luftwaffe pilot, who had flown both the Bf-109 and a captured Mustang, described the experience as being akin to comparing a Volkswagen to a Mercedes. This was perhaps somewhat unfair to the Messerschmitt, which had been an excellent fighter by the standards of 1939. But by 1944, the 109 was a refined version of an increasingly obsolescent design, constantly upgraded to maintain a semblance of competitiveness, but fundamentally limited by its original configuration. The Mustang, in stark contrast, was an entirely new design, incorporating the very latest understanding of aerodynamics and meticulously optimized for the specific mission of long-range escort. It had no inherited limitations, no compromises made to accommodate outdated pre-war assumptions. It was what a fighter could be when designed with perfect information about what the realities of the war actually required. The German engineers studying the captured Mustang were particularly fascinated by the laminar flow wing. This revolutionary design, pioneered by NACA, maintained smooth airflow over a greater proportion of the wing's surface, significantly reducing drag and improving overall performance. In theory, German designers possessed a solid understanding of laminar flow. In practice, however, they had never successfully implemented it in a production fighter. The required manufacturing tolerances were unbelievably tight. Any surface imperfection, any rivet head protruding even slightly above the surface, any imperfection in the paint texture, any degree of surface roughness would disrupt the laminar flow and completely negate its intended benefit. American manufacturing had somehow managed to achieve these incredibly tight tolerances reliably and consistently in mass production. German manufacturing, while undeniably renowned for its precision, simply could not match this level of consistency at scale. The Mustang's wing was a triumph not just of design, but of industrial process control. This pattern repeated itself across multiple systems. The Packard Merlin engine was not inherently superior to German engines in terms of basic design, but American manufacturing quality control ensured that each engine performed reliably to its exacting specifications. German engines of the same period exhibited a far greater variability in performance between individual examples. Some were outstanding, exceeding expectations. Others were frankly mediocre. The Americans delivered unwavering consistency. The Mustang's fuel system was yet another revelation. The aircraft carried fuel in multiple tanks, fuselage tanks, wing tanks, and external drop tanks. An elaborately designed fuel management system allowed the pilot to meticulously balance fuel consumption to maintain the proper center of gravity throughout the duration of the flight. The tanks themselves were self-sealing, lined with a sophisticated rubber compound that would swell when punctured by bullets, effectively sealing small holes and preventing catastrophic fuel loss. German fighters also possessed self-sealing tanks, but the American implementation was undeniably more robust and more reliable. More importantly, the sheer quantity of fuel that the Mustang could carry while still maintaining exceptional performance testified to a level of design integration that German engineers could only admire from afar, a feat they could not replicate given the myriad constraints they faced. Even small details demonstrated the level of thoughtfulness that had gone into the Mustang's design. The cockpit layout was remarkably logical and uncluttered, providing the pilot with a clear and intuitive workspace. The gun sight was simple yet exceptionally effective. The radio equipment was reliable and remarkably easy to use. The landing gear was robust and forgiving, easily tolerating operations from rough and uneven terrain. These might seem like minor points taken in isolation, but in aggregate, they represented the critical difference between a good aircraft and a truly great times one. German fighters often excelled in raw performance metrics, but they frequently suffered from nagging reliability problems, complex maintenance requirements, or peculiar design quirks that made them challenging to fly, especially for less experienced pilots. The Bf-109's notoriously narrow landing gear made ground handling treacherous. Tragically, more pilots were lost to landing accidents than to some types of combat engagements. The Bf-190's BMW radial engine was undeniably powerful, but also notoriously temperamental, requiring meticulous management to avoid catastrophic overheating. The Mustang, in contrast, was almost universally regarded as a pilot's aircraft. It was forgiving of mistakes, reliable in operation, and effective in a wide range of combat situations. These qualities made it supremely well-suited to the unforgiving realities of wartime operations, where pilot skill levels varied greatly and where aircraft simply could not receive perfect maintenance. By the autumn of 1944, the Mustang had definitively achieved what German aviation planners had once believed to be utterly impossible: true air superiority over the very skies of Germany. American fighters relentlessly patrolled the skies of Germany with impunity. Luftwaffe fighters, when they dared to take off despite chronic fuel shortages, were relentlessly hunted by Mustangs, which could outperform them in almost every conceivable respect. The German response became increasingly desperate. The Messerschmitt Me 262 jet fighter, when it finally entered service in significant numbers in the autumn of 1944, was undeniably faster than the Mustang, capable of speeds exceeding 850 kilometers per hour. In terms of raw speed, it represented a quantum leap in technology over propeller-driven fighters. But the Me-262 arrived far too late and in far too few numbers to meaningfully alter the course of the war. Total production was around 1,000, 400 aircraft, but many never flew a single combat mission due to crippling fuel shortages, a severe lack of trained pilots, or the relentless Allied bombing of their airfields. The jet engines themselves were notoriously temperamental, with a service life measured in hours rather than the hundreds of hours a Merlin engine could operate reliably. The Me-262 required long, meticulously maintained concrete runways for takeoff and landing, making it particularly vulnerable to Allied fighters, which would often loiter near known jet bases, patiently waiting to pounce on Me-262 seconds when they were most vulnerable. During takeoff and landing, when their superior speed advantage was temporarily nullified. More fundamentally, the Me-262 represented a tactical dead end for Germany. Even if it could have been produced in unlimited quantities, even if it had been perfectly reliable, it simply would not have changed the fundamental strategic situation. Germany was losing the war not because it lacked fighters that were fast enough, but because it lacked fuel, trained pilots, a functioning industrial base, and defensible territory. The Mustang and other Allied aircraft were not just winning individual air battles, they were systematically destroying the very infrastructure that made German resistance possible. American and British heavy bombers, relentlessly escorted by Mustangs, were systematically destroying Germany's synthetic fuel production. By early 1945, the Luftwaffe was effectively grounded, not because there were no aircraft available, but because there was no fuel to fly them. Hundreds of meticulously maintained fighters sat uselessly on airfields, unable to take off. Pilots deserted non-operational aircraft, seeing little point in remaining. Sophisticated technology, advanced design, the accumulated expertise of the German aviation industry, all rendered utterly irrelevant by a simple lack of fuel. This was the ultimate devastating irony that Tierfelder's test flight so presciently foreshadowed. Germany had poured immense resources into developing advanced fighters, constantly refining the Bf-109 and the FW-190, developing the revolutionary Me-262, and pursuing numerous experimental designs. But the Americans had pursued a fundamentally different and ultimately more successful strategy. Build a very times good times fighter, build it in overwhelming numbers, and then use it to enable a relentless strategic bombing campaign that would systematically destroy the enemy's ability to wage war. The Mustang was not the most technologically advanced fighter of World War II in terms of raw technological innovation. The Me-262 was undeniably faster. The Soviet Yak-3 turned tighter at low altitudes. The British Spitfire Mark 14 possessed certain advantages in maneuverability, but the Mustang was the time's most effective times fighter because it combined good enough performance with excellent reliability, superior range, and, most importantly, availability in numbers that made strategic impact feasible. This was a crucial lesson that transcended the specific circumstances of World War II aviation. Technological competitions are not won simply by achieving the highest performance in individual systems. They are won by achieving times-adequate, times-performance in systems that can be reliably manufactured, efficiently maintained, and employed on a massive scale. The Germans relentlessly pursued perfection in individual aircraft designs. The Americans wisely pursued adequacy at overwhelming scale. When Theopelder landed the captured Mustang at Rechlin after his pivotal 47-minute test flight, he possessed information that the German leadership desperately needed. He had definitively verified that the combat reports were accurate. The Mustang was every bit as good as Luftwaffe pilots were claiming. In fact, it was probably even better, as combat reports were almost always colored by the fog of war, confusion, fear, and incomplete observation. The test flight provided clinical, objective data, but information without the capacity to act upon it is just another form of failure. The Luftwaffe simply could not build a Mustang equivalent. They could not train enough pilots to fly their existing fighters. They could not produce enough fuel to keep those fighters airborne. They could not adequately protect their fighter production industry from systematic destruction. Knowing that you are losing is a very different thing from actually being able to prevent losing. The captured Mustang at Rechlin became a potent emblem, though perhaps not a consciously recognized one at the time, of the yawning gulf between German assumptions and Allied realities. It sat on a German airfield bearing Luftwaffe insignia, yet it remained fundamentally American. The paint did not alter its underlying performance. The markings did not change its inherent capabilities. It was, quite simply, what it was. irrefutable evidence of American industrial and technological prowess that had undeniably surpassed Germany's. In post-war analyses of World War II aviation, historians and engineers have extensively studied the Mustang's design and its profound impact on the air war. The consensus is clear and unequivocal. The P-51D was one of the most important aircraft of the war, arguably the single most important Allied fighter in the European theater. Its arrival in large numbers in early 1944 coincided precisely with the collapse of effective Luftwaffe resistance. This was not a random coincidence. The aircraft directly enabled the strategic bombing campaign that crippled German industry. It achieved air superiority over Germany, making possible ground operations in France and subsequently in Germany itself without significant interference from the German Air Force. It forced the Luftwaffe onto a defensive posture from which it could never escape. And it did all of this while being fundamentally simpler and cheaper to manufacture than many German fighters. The Mustang required approximately 25,000 man-hours to produce. A Focke-Wulf W190 required approximately 13,000 man-hours. But the Mustang was demonstrably more capable, meaning that the American investment yielded a far better return. When you factor in the Mustang's superior reliability and longer service life, the economic advantage became overwhelming. This economic aspect is often overlooked in discussions of military technology, but it is absolutely decisive. Wars are not ultimately won by the side with the absolute best equipment. They are won by the side that can produce good enough times equipment to sustain operations while simultaneously denying the enemy the ability to do the same. The Mustang was good enough to win air superiority while being cheap enough to produce in truly decisive numbers. For the German test pilots at Rechlin, this crucial lesson was conveyed starkly, undeniably, through the visceral experience of flying an enemy aircraft that outperformed their own. The intellectual understanding that Germany was losing the war was transformed into a palpable, material reality through the control stick of a captured Mustang. Werner Felder continued his work as a test pilot during the final, desperate months of the war, evaluating new German aircraft as they became available and briefing pilots on the capabilities and limitations of Allied equipment. By early 1945, this work had largely become academic. There was precious little fuel, dwindling numbers of pilots, and no realistic prospect of reversing Germany's rapidly deteriorating fortunes through advances in aviation technology. He witnessed the chaotic evacuation of Rechlin as Soviet forces relentlessly advanced. The carefully maintained test facility, the vast storehouse of accumulated technical knowledge, the meticulously curated collection of captured aircraft, all were abandoned or systematically destroyed to prevent their falling into enemy hands. The Mustang he had so expertly flown vanished in this swirling chaos, likely destroyed in place or perhaps damaged beyond repair, and simply left for scrap. After the war, Thierfelder participated in extensive debriefings with Allied intelligence officers who were painstakingly compiling comprehensive assessments of German aviation programs. These interviews produced a remarkable trove of invaluable technical documentation as German pilots and engineers frankly discussed their experiences and openly acknowledged Allied technical achievements. The suffocating ideological constraints of the Nazi era were finally lifted. People could at last speak honestly about what they had experienced, free from the fear of reprisal. The consensus among Luftwaffe test pilots was remarkably consistent. The P-51D Mustang reigned supreme as the best all-around fighter aircraft of World War II. While some German pilots, even after the war's conclusion, would stubbornly cling to the notion that certain German designs possessed specific advantages, the FOAM 190D9 perhaps, exhibiting superior diving capabilities, the Me-262, boasting demonstrably higher speeds in level flight, or the Bf-109K-4 showcasing a faster climb rate, particularly at lower altitudes. The Mustang consistently outperformed them all when judged holistically, across the spectrum of performance metrics, and encompassing the diverse and unpredictable nature of aerial combat scenarios. This acknowledgement represented a seismic shift, a stark and utter reversal of the narrative deeply ingrained within the Luftwaffe. These pilots had entered the war confident, secure in the belief that German aviation technology held an insurmountable lead. They emerged from the ashes of defeat, forced to concede that an American aircraft, conceived in 1940, painstakingly refined throughout the intervening years, and mass-produced on an unprecedented scale, was undeniably superior to anything Germany could bring to bear. Imagine the psychological turmoil, the profound disorientation inherent in such a revelation. It must have been akin to a complete shattering of long-held convictions, a fundamental reevaluation of everything they thought they knew about aerial warfare. But for men like Theo Osterkamp, or perhaps Erich Rudifer, figures rigorously trained in the exacting discipline of flight testing, where objective measurement and verifiable data held sway over propagandistic pronouncements and nationalistic fervor, the evidence presented was irrefutable. The cold, hard data, meticulously gathered and analyzed, spoke volumes, painting a clear and undeniable picture of American engineering prowess, a testament to their innovative designs and relentless pursuit of perfection. Thank you for watching. To delve even deeper into these fascinating historical analyses, be sure to explore the other videos now appearing on your screen. Uncover further layers of the stories and personalities that shaped the tumultuous aerial battles of World War II. These accounts offer even greater insights into the breathtaking technological advancements, the innovative strategies, and the indomitable human spirit that defined this pivotal period in aviation history, a time when the skies became a battleground and the fate of nations hung in the balance.